Hey guys, my name is Akash. Today I'm going to talk about a library that I just built recently called RocketRPC. RocketRPC allows you to access server-side objects from your client. This can be any method or object that you define, including a Prisma client, a part of a Prisma client, or any other ORM object that you want to pass to the front end. And I gave a demonstration of this at Svelte London recently, so let's jump into it. So my name is Akash Joshi. I'm a software engineer at Meta. And today I'm going to talk about how we can destroy the client-server barriers with Typescript. So I think I've talked enough about what this does and what it's about. Let me show it in action. So I'm just going to jump directly into the code right now and show you what the server looks like at RocketRPC. So this is the server. It's 19 lines of code, and it doesn't really get any more complex than this. How you use RocketRPC is by first importing the server from the library. So this is currently importing from my local source. You would import from RocketRPC instead, of course. This is the complete API object. And inside of the API object, you basically write all of the methods that you want to access on the front end. And this can get more complex as well. And I'm going to get into that in a second. You export the type from your original object. That's how a lot of TypeScript-based RPC frameworks also do that for type inference, because that's the sort of the easiest way. And then you just pass in a port number or any HTTP relevant object. So if you are using any HTTP framework like Express, Fastify, or anything else, you can reuse the same object here and host RocketRPC on the same server. And then you pass in your API object, which was literally like these few lines of code on any other methods that you want to import in here. And then you just pass in your server options. For example, right now my front end is hosted on a different port number, so I'm just opening it up to everything right now. And now, let me get into the front end. So for the front end, I have a simple application in front of you all right now. This is an app which is sort of integrated into the RocketRPC server at the moment to get the data that you see at the top. And then at the bottom, it's like a simple like to-dos app. You add some data in here, and then it creates a bunch of to-dos, and then you can change the status of it to done or not, and then remove it from the screen, stuff like that. It's pretty box standard. And then what we are going to do right now, or try to do at least, is to add persistence to this by calling Prisma from the front end. So this will be fun. Right now, let me explain the client code a little bit as well. It's from here to here. So from line number 2 to line number 12 is where you should be looking at. At line number 2, I'm importing the client from the client. I was having issues in Wheat for doing like these automagical imports where you sort of destructure your object from the source. So I had to import it directly. We import the types again because we need type inference on the front end. And here I'm declaring the client, which is again declared in one line. I'm initializing the client, passing in the types from the server, passing in which port I should connect to. So in this case, it's pretty straightforward, localhost 8080. And then what it returns is all of the methods that I had passed in on the backend. So this ping that I've passed in, the sum, I can destructure all of this on the front end, and all of this with type completion even. So what we are doing here is calling the ping method. The ping method takes an argument and returns a string like pong, and then whatever argument you are passing in. And we are calling the ping method here, setting it to the ping response variable, state variable, and then displaying it there. And that's exactly what we are seeing here. If I replace world with anything else, I mean, as you might expect, it just hello Svelte, I would say. And it will just replace it with whatever I pass in instead. So I mean, that was the pretty straightforward part. Now we'll get into the interesting bit. So I'll expose the Prisma client from here now. This is always the most interesting bit, trying to make it figure out where the Prisma server is. So at Prisma/client, that should work now, I think. And now I can access Prisma on the front end. That's great. So I'm going to use this to add persistence to this layer, as I was saying. So we need to save to-dos to the DB and also return them from the DB whenever we refresh. I won't get too into the depths of it, but at least show you how it might work. So to store this list of to-dos at the moment in the front end, I'm using a variable called to-do list. And this to-do list is typed with to-do, which is currently a custom type that I've created. Instead, let's type this with the actual Prisma type. So let me go into my Prisma server at the moment. The schema is visible on the screen right now. So yeah, this is sort of like the standard to-do schema that I've created. The only two fields that we should be interested in at the moment is the status field, which is the Boolean, whether it's done or not, and the text field, which is like what is actually stored in that to-do list, to-do string. So yeah, right now I just import this from Prisma, from the actual Prisma client instead. So this gets all of the types of, yeah, the Prisma schema basically. And what we are trying to do next is set the initial value to whatever we can get from Prisma. So I will do prisma.todo.find many. And then this, of course, returns a promise. So I add a .then at the end, and then set that value to to-do list. So I will do something like new or like stored to-dos probably. As you all know, naming variables is the most difficult problem in programming. So yeah, I'll set this to stored to-dos. Of course, it won't do anything right now because we don't really have anything in our DB. But as you can see, it's starting to make calls to the backend at the moment. And okay, even though yeah, it's not logging anything because there's nothing there to log. What I'm going to do next is replace the add to list function. As you can see, it's an on-submit function which prevents reloads on submit and then sets the to-do list to whatever the new list item we added is. So instead, I'm just going to do prisma.todo.create, and then it expects some data, which is basically like whatever text I'm submitting at the moment. And wait, just a sec. Yeah, I need to add a value to it. So that should be, I guess, new. Yeah, let me just check what's binded on input at the moment. Yeah, it's new item. So I just drop in new item inside. And then this creates a new Prisma object. And then whatever object that this creates, so new to do, I set that on my list here. So I just bring that back up and then replace this with the new to do instead. And yeah, that should stop complaining now. And if we go back here and if I add a few nodes, so new to do, then yeah, I'll just keep adding stuff. This is actually happening in real time. Yeah, thank you. And yeah, if I refresh my page right now, this is all like fresh data you're getting from your Prisma DB. This is all stored in your database. So yeah, let me get back into the slides again. So that was the exact problem I was trying to solve. I was like bored of writing APIs all of the time, and I wanted to just expose my ORM on the front end. There's some security stuff on top of this. Don't worry, hackers won't be able to access your whole DB, but we'll talk about that later. So yeah, just wanted to create that basically and solve how to create apps fast. And it doesn't just work in contexts where you expect the front end to be a browser or like the client to be a browser. This can work for inter-process communication as well. So imagine that you're writing GraphQL resolvers and your data is stored on a Prisma DB somewhere. You don't know where, but like it's there out there somewhere. So you expose that data via RocketRPC, of course, and then you can call that, call the Prisma here. The GraphQL resolver doesn't need to know what the DB secrets are. As you can see, we aren't really passing in any secrets. It's like the server URL or something else, and then maybe you use an authentication token to authenticate yourself to the server. But other than that, the client doesn't need to know what the secrets of your Prisma DB are. It's not limited to Prisma either. You can use something like Sequelize, for example. So you could use, you could connect Sequelize to your sequelize to your SQLite data in your memory, initialize a user class, and then expose a get users method, which returns all of the users that you have. And then now you could have like data from two sources. So you could use data from your SQLize and data from your Prisma in the same application. And another problem with Prisma at the moment is that you cannot have multiple clients. So you're limited to sort of one client at the moment, and this solves that problem as well. So you could have multiple Prisma clients imported from different servers, and then you can call all of them natively on the front end. So yeah, that was sort of what I was going for there. And why is there an empty slide? Okay, yeah. So I hope by now this is what your expression is, and I hope your mind was blown by looking at the school example. And you might ask, how does all of this actually work? And yeah, now I'll get into the depths of my library, because I want to show how all of this technology works as well. Don't be scared, it's like less than 200 lines of code, and it's pretty simple. The first thing that it works on is object proxies. So I was talking with Dan, who used to be an engineer with Prisma recently, and we had a discussion around object proxies as well. And did you know that the Prisma client also uses object proxies? So object proxies are a really like underused thing in JavaScript at the moment, and I think there's a lot of cool stuff that we can build with them. Let me go into the source code of my library for a second here. So if I go into the client here, I can hide that now. I don't really need that. So let's have a look at what an object proxy actually does. So the object proxy that I'm using to handle all of the API calls and everything that happens on the front end side is called client proxy. I'm creating a proxy here which has get and apply, and that is all I need. Get is basically whenever you're trying to access a property on the front end. So if we go back to our example where we were sort of doing like prisma.todo.find many. So whenever someone tries to access todo, they're actually accessing the get property on the proxy. And we are sort of building the path on the front end of what method the user is trying to access. I generate the complete method on the front end by every like dot operator that the user accesses. And then apply is called at the end. Apply is sort of similar to how function.apply works. You basically call a function, and then I generate this complete path. And I use this complete path, send it to the backend, and then based on some socket.io magic, it fetches the response from the backend. I'll go into the details of that as well. So the next up, it's socket.io, which is on the network layer. Why socket.io? It's because I didn't want to care about the network layer. This library isn't supposed to be about the network layer. It's supposed to get out of your way and let you do your job. And socket.io is like one of the fastest WebSocket layer, which is also reliable out there, because socket.io downgrades to HTTP long polling if your system doesn't support socket.io. And the way I'm using socket.io is pretty straightforward as well. I'm just connecting to a socket.io server on the backend, and then I'm emitting the function call here with all of the params, which are basically like what arguments am I passing in, what path do I want to call on the server, and then whenever the backend responds with whatever the result is, then I just resolve the promise that I have on the front end and return that data to the user. And lastly, after socket.io, we have TypeScript, of course. And TypeScript is actually what makes all of this work and what is bringing us all of these cool frameworks like TRPC and RocketRPC as well. So how am I using TypeScript here? Basically, I'm passing a generic to my front end, and this generic then sort of I'm wrapping like a promisify record sort of type around it, which promisifies all of the return types, because all of the return types on the front end need to be promises, because everything's traversing over the network layer. So it's basically this one type which is sort of doing all of the magic that we see around TypeScript here. And yeah, that's pretty much my talk, I guess. Thanks for watching so far. Yeah. Yeah. So I'm looking for contributors at the moment, and also users, of course. So you can go to rocketrpc.com to try it out. I'm also at the Writing Dev on Twitter, so you can reach out to me in case you have any questions. And yeah, I'm up for Q&A right now.